All right. Last week we went through quite a few of the full calculations so we could get to where we wouldn't have much to do this week. So I think we got three left that we're going to look at. And once we get through those, we will be done with, I guess, let's see, we missed 1 week. So we're in the second week. So what we do, 12, 30, I guess we did what, about 14 weeks?
Yeah,
No, 14, that'd be 16, say
yeah. I think
17.
it'll be
17.
16 or 17 by the time it's said and done.
17 weeks it took us doing this, going through all the calculations since start of the year. So I hope everybody enjoyed going through all these full calculations or going through all the different calculations. It it's been fun, but man, there's a lot to cover. But
Hey, I want to give you a big round of applause for everyone. That's awesome that you put that together. Free class for everyone.
yeah, there was a lot to cover. Now, this one here, what we're going to be looking at is a school. All right. And the service coming to it is 277 40 volt 3-phase 4-wire service, and we've got a 20,000 square foot school. We got 4,000 square foot of convention type area, and then we got 1,000 square foot of library area. And all the lighting that's going to be in this building is going to be 277. So just remember is when we do the lighting loads and everything, that when you're looking at the fixtures here, we will have some 120 volt loads here, 208 volt loads, and some 480 volt load here. But when we're looking at the lighting, we're going to do all the lighting based on the square footage here. Okay. So, and then for our 120 volt single phase loads, this will be our second load. You'll notice right there we got 170 receptacles at non-continuous duty, 40 receptacles at continuous duty, and then we got 160 foot of multi-outlet assembly, and we're going to do it at simultaneous use. It won't be non-simultaneous. Okay, so that basically means we're just going to take it at 180 VA. And then let's look at my special loads here. Now we're going to get into special type loads here, and these are going to be my kitchen loads and my cooking equipment loads. And you're going to see we got 208 volt single phase kitchen equipment, and then we've got 208 volt single phase cooking equipment. Now for my kitchen equipment, I got two 1 kW toasters. We got four 1.5 kW refrigerators and two 1.5 kW freezers. And then for my cooking equipment, I got four 9 kW ranges, three 10 kW ovens, and four 3 kW fryers. And then we got two different type of motors here. So you'll notice, um, looking at this here, we've got a 208 volt single phase motor loads. So we got three 1 horsepower vent hood fans and three 3/4 horsepower grill vent fans. And then for my 480 volt 3-phase loads, we got 18 3/4 exhaust fan loads. All right. So we're going to break this down and we're going to set this up. Now, one of the things, I'm going to go right to this next one here. I want to show you here. Usually I have 7 loads, but one load we didn't have in here was refrigeration loads. Okay. So if I had refrigeration loads in here, it would actually be my fourth load I was going to calculate. All right. But we're not doing it in this one. All right. So let's look at this. Now, uh, we took a look at this the other day, and I said, remember, when you look at the uh, uh, your listed type units that are in there, and you're looking over at table 220.12, I said, look down at the note because the note's going to tell you everything's taken at 100%. So when I look at a school load, it's going to tell you take it at 3 VA, and we had 20,000 square foot of that. That'll give me 60,000 VA. Take it at 100%. That will give you the phase and neutral load as exactly the same here. And then when I go in and I look at my uh, uh, my convention area here, auditorium, here we got 4,000 square foot, and we had 1,000 square foot for the library area. So I'm going to take the 4,000 square foot time 1.4. I don't know why that says 4,000. That should say 5,600. I need to fix that. Then you take that at 100%. That'll give you 5,600 VA, and then we had 1,500 times 1.5. That don't look right. Looks like I made a mistake here. I sure did.
Hey, really quick, James. One thing I want to just bring up is Juan, really quick, asking about the original manufacturers. They provide built-in GFCI, which complies with the NFPA and NEC personnel protection. I 100% agree, Juan. The problem is that Code Making Panel 2 seems to think that they are responsible for protecting the branch circuit. So they're saying that in some cases they recognize that original manufacturers built in GFCI, and in other cases they don't. And in EBSE they don't, because it's 20 milliamps, 20 milliamp personnel protection, and they're saying it has to be 4 to 6, which is wrong. So that's my opinion, and that's just my opinion of the interpretation. If you have like a water cooler that's in a school with a bunch of kids, 20 milliamps just fine. You know, so
that's right, and that goes back. That goes back to the testing and everything that is required by OSHA out of the national recognized testing laboratory to take those things into consideration. That's exactly correct.
True.
And I remember that. I forgot to delete that. I did that last week, and I made the changes to that when we did it. So that calculation already covered. I thought something didn't look right there. I've already gone back and made those changes. All right. Now, because we did the school and we were on the restaurants, what we were going to start this week. That's what it was. So we had a 6,000 square foot restaurant here. Now, what I want to point out here is when we come over here and we start looking at this, you're going to see two loads. We got the general lighting and receptacle load, and then you're going to see your special appliance. But right here, you're going to see motor and heating, AC and large motor. You're not going to see a compressor load here, okay, for refrigeration. All right. So
hey, I have a question for you. Is there anything in there that says this is a 100% electric restaurant, or is this just the electric loads of a restaurant?
Well,
is there anything in there?
They're electric. If it's gas, we'll tell you it's gas.
But I mean, does it have to be 100% electric restaurant?
No.
I heard a code guy say something that it's a 100% electric restaurant or something. And I'd never heard of that before.
No, we actually have a calculation where we go in and show you loads that are have gas, and there's no electric load there.
Okay, gotcha.
So we actually go through and show you all different types of things on how to calculate that. But this in here, we're just giving you the different loads and what you need to look at. So
I was thinking to myself, if an engineer built that, that'd be really weird to do an all electric restaurant.
Sure. And then if you look here, you've got a 6,000 square foot restaurant. Then you look at your 120 volt loads. We separate them for you. We got 35 foot of lighting track. We got 180 VA ballast for outside lighting. Then we got 1,200 VA for the sign. Okay, that will go in with the 6,000 square foot for the restaurant load. So that'll be a lighting load. Then you got receptacle loads here. I got 35 receptacles at non-continuous, 30 receptacles at continuous, and 20 foot of multi-outlet assembly. And then you start looking at your special loads. Well, what are my special loads? My special loads that I get into is we're going to deal with is a special load here could be heating or AC, but that's going to be a non-coincident load. So you're going to take, and I can already tell you the heating unit's going to be the largest. That's going to be 50 kW because I got two of them. Then your other special loads are what? Kitchen equipment, and I've got a 3600 VA boiler, 2600 or two 2600 VA deep fat fryers, 20 amp walk-in cooler, a 6500 VA water heater. Those are 208 volt three-phase loads. And my single-phase loads, I have a 13 amp freezer, 8,000 VA cooktop, 10,000 VA oven, 11,000 VA range, a 14 amp refrigerator, and a 3,700 VA ice cream box. And then my motor loads here are a vent hood fan at 6,950 VA and a grill vent fan at 4,750 VA, 58 VA. So when you look at the sliding load, all you're going to do is look at table 220.12, because this is a listed top occupancy. And I'm going to go over and look at a restaurant. It's going to tell you that you take that at 1.5 VA. So 6,000 square foot times 1.5 VA is 9,000. Take it at 100% based on the note under table 220.12, and that'll give you 9,000 VA for the neutral and the phases. And if you look, we got a check mark there beside for the neutral, and we got a bullet mark there beside for the phase load. Then my track lighting, we had 35 foot. So I'm going to divide that by 2, go over and look at 220.43B. It says for every additional foot here, divide by 2. So that's going to give me 17.5, and multiply that at 150 VA gives me 2,625. We said it was being used continuously, so I'll take it at 125%. That'll give me 3,281 VA. Since once again, it's 120 volt loads, I'll put a check mark there by the first calculation. The second portion of that being used at continuous, taken at 125%, I'll put a bullet there. Then I look at my outside lighting load. I had 10 units there that were rated at 180 VA each. That'll give me 1,800. I said they were at continuous duty. Take it at 125%. That'll give me 2,250 VA. Put a check mark there for the 1,800 and a little star like bullet there for 2,250 VA. And then we had the sign load. If you look at 220.14F and 600.5A, the 1,200 VA is the very minimum a sign can be, and it was at 1,200 VA, so I'll take it at 100%. That's 1,200 VA. That's my neutral load. It was continuous use, so I'll take it at 125%. That gives me 1,500 VA. Add all my bullets up here, the 9,000 VA, the 3,281 VA, the 2,250 VA, and the 1,500 VA, and that'll give you a total load there of 16,031 VA. All right. Now,
nice.
That takes care of lighting load. Now I've got my receptacles here. We said we had 35 non-continuous use receptacles. If you go look at 220.14I, it tells you take each one of those at 180 VA. That'll give me 6,300 VA because it's for 120 volts. That will be my neutral and my phase load. Then if I looked at my continuous loads, I had 30 of those, naturally just like the non-continuous. Take it at 180 VA, that'll give me 5,400 VA. That's my neutral load. Being continuous, you take it at 125%. That'll give you 6,750 VA for my phase load. Then I look at my multi-outlet assembly here. It was simultaneous. I had 20 foot of that. If it's non-simultaneous, I'd do different, but since it's simultaneous, you just take it at 180 VA for each foot. That gives you 3,600 VA, and that's your neutral and phase load. Then add your 6,300 VA, 6,750 VA, and the 3,600 VA, and that'll give you a total load for your receptacle here. If your receptacle is a 16,650 VA. All right. Now, that leads me to what I'm going to get to last, or the next part, which is my special loads. Now, any motor loads, heating loads, just put them off to the side. Anything that's left goes right here where? Special appliance. Okay. And if I had refrigeration loads, that would be my compressor loads. That'd be another group. Okay. So everything that's left here, we had our freezer load. We said you had 13 amps, and you want to multiply that at 208 volts. That'll put it in VA form. That's going to give me 2,704 VA. Our cooktops, I had 8,000 VA. My ovens, I had 20,000 VA because I had 2 of those at 10,000 VA. My range was 11,000 VA. My refrigerator was rated at 14 amps. Multiply that at 208 volts to put it in VA form. That'll give me 2,912. My ice cream box was 3,750 VA. The boiler was 3,600 VA. I had 2 deep fat fryers at 2600 VA. Multiply that by 2, that gives you 5200 VA. Then I had a 3-phase walk-in cooler. Okay, so I'm going to take the 208 volts times 1.732. That's going to give me 360 volts. So I'll take 20 amps times 360 volts, gives me 7200 VA. And then I had a water heater at 6500 VA. Just add it up. That's going to give you 70,866 VA. Now, you're going to go over and look at table 220.56, and I've got more than enough units here. So it's going to allow me to put a demand factor on this. And the demand factor it allows here is 65%. I take that at 65%, and it's going to tell me the phase load here is going to be 46,063 VA. Okay? Then I'm just going to look at calculating my motor loads. My hood fan, we had 7,321.6 VA. All motors take it what? 100%. And then I'll do one of the largest at the end at 25%. My grill vent fans were 4,742 VA. Take it at 100%. Add them up. That gives you 12,063.6 VA. Then I said the largest between the heating and AC naturally was the heating. I had 2 units at 25 kVA. Take that at 50,000. Now I'm going to look at what is the largest motor load. I look at my hood fan. I look at my grill vent fan. Well, I can go through, look at this, and I can already look and see which one's the largest. It's my walk-in cooler at 20 amps. So I'll take the 20 amps at 360 volts. That gives me 7,200 VA. I take that additional largest motor at 25%, gives me 1,800 VA. And then I'm going to come back here and I'm going to add these up here. The 16,031 VA, the 16,650 VA. I'm going to add the 46,063 VA, the 12,063.6 VA, the 50,000 VA, and the 1,800 VA. And that's going to give you 142,600 VA. That's as simple as it gets. So then I'm just going to look at doing my neutral. Well, all I'm going to do is I'm going to go back here and I'm going to take all these check marks, add them up. Then I'm going to do the receptacle check marks, add them up. Then if I look, I have no more check marks here, okay, because those are not 120 volt loads. So if I look at my lighting load, I had 14,625 VA of neutral load. My receptacle load was 15,300. Added up gives you 29,925 VA. And then you just take the phases in neutral, divide it by 360, and there's your amperage. Okay? That's how simple it is to do the calculation. And one thing I want to point out that I've done here, I've never changed my calculation. Now I'm going to look at something different here. This is the last one. This is for a welding shop. Now, you're going to notice I'm not going to reference table 220.12 here. And why am I not going to do that? Because this particular occupancy here, this welding shop, is not listed in table 220.12. So what that's going to do, it's going to tell me all these lighting loads I'm going to have to calculate separate. Gotcha. Okay, so all lighting loads that are separate are there. There won't be, you know, a VA that's going to be put on for the square footage here. And you'll notice
is that considered an optional method or a standard method?
This is standard. Everything I'm doing is standard here. Okay.
Gotcha.
So, and if you look right down below here, we tell you, no, we put a note here. A welding shop is not a listed occupancy in table 220.12a. Okay. So we're telling you. So I'm going to look at my 120 volt loads here. You got your lighting loads here, and then you got your receptacle loads here. I've got 8,500 VA inside lighting loads. I got 680 VA ballast for my outside lighting loads. I've got a 1,200 VA sign load. That's the very minimum, so that'll work. And then I got 50 receptacles. And then I'm going to look at my 208 volt 3-phase loads. I got two 12 kW heating units. And then I got a 6,000 VA AC unit. I can already tell you the 24,000 VA is going to be more than the 6,000. So we'll be using the heating unit for the non-coincident load. Then I'm going to look. I've got a 7.5 horsepower air compressor. I got a 1.5 horsepower grinder. and then I've got some welders here. Okay,
Nice.
I've got one 11 kW and one 9 kW resistance welder. There's two of those at a 30% duty cycle. Then I got two motor generator arc welders at 80% duty cycle. One is 12 kW and one's 10 kW. And then I got two non-motor generator arc welders that are 90% duty cycle. I got a 1 kW and one 9 kW. Now let me say something before we get started.
Okay.
The non-motor and the motor generator arc welders, you're going to be looking at 630.11A, and then you'll look at 630, we'll just say 630.11 and 630.12. When I get to the resistance welders, you're going to look at 630.31. Okay?
Nice.
Now, when I come in, I get ready to start doing this calculation. You're going to notice there's no table 220.12 here. All right? I'm going to do everything individual for calculating the lighting loads. For inside lighting, I had 8,500 VA. At 100% gives me 8,500 VA, put a check. Then we tell you it's at continuous. Now, one of the things you're going to notice, since this wasn't listed in table 220.12, you're going to notice I'm putting 125% on this. Whereas if I'd have been a listed occupancy, I would have just done this at 100%, because the note underneath the table gives me the permission. Now,
right.
Since this is continuous, I'm going to take that 8,500 at 125%, and my phase load here is going to be 10,625 VA. Then I look at my outside lighting load. I had 6 units out there at 180 VA each. That gives me 1,080 VA for my neutral load. They were continuous, so I take it at 125%. That'll give me 1,350 VA for my phase load. Then I had a sine load. We had it at non-continuous. More than likely, they'll keep it on for 3 hours or more at night. But this is just sort of make you think, because they could ask you a question like this on the test. It was non-continuous, so I take it at 100%. That's 1,200 VA for my phase and neutral. Add my phases up, 10,625 VA for the inside lighting load, 1,350 VA for the outside lighting load, and 1,200 VA for the sign lighting. That gives me 13,175 VA. Then I look at my receptacle load. The only receptacle load I had were 50 receptacles. They were continuous duty. So looking at 220.14I, I take that at 180 VA for each receptacle. That'll give me 9,000 VA for my neutral load. Since it's continuous, I take it at 125%. That'll give me 11,250 VA, and that'll be for my phase load. Okay?
Nice.
Now, that takes me into my special loads. All right? Now, the special loads, when I look over here, let's go one further. You got your compressor and motor loads, and you got your heating and AC and largest. So I'm going to calculate these separate. Everything that was left once these are pulled out for my heating and AC and my compressor and motor loads goes in where? Special appliances again. Okay?
Right.
So don't get confused. Just look at it this way. Now, let's look at resistance welder. And I told you when you look at this, you're going to look for resistance. You're going to look at 630.31. Okay?
Right.
And if you look at each one of those, we had 11,000 VA welder and a 9,000 VA welder, and that 30% duty cycle on both of them. I look at table 630.31A2, and it tells you that duty cycle that you can apply the percentage at is 55%. So 11,000 at 55% is going to give me 6,050 VA. The 9,000 VA at 55% is going to give me 4,950 VA. Now, what it allows you to do after that, it allows you to take here the smallest in 630.31V. It's going to allow you to take this particular one here at 60%. Okay? So all I'm going to do is take the largest 6,050 VA, and then I'll take that 4,950 VA at 60% will give me 2,970 VA. Add those up, and now you've got a total resistance here. A total welder resistance welder load of 9,020 VA. Now, I'm going to tell everybody when you're doing this, you really need to look at this calculation, because right here in 630.31B, they're going to give you the permission at this 60% here. Okay.
Right.
And most people will miss this. And this could be, they could just ask you how to calculate for a welder. You need to understand how to do this. Now,
True.
when I get to the motor generator arc welder in 630.11A, I had an 80% duty cycle. And then for the non-motor, I had 90% duty cycle. And I'm going to look at 630.11A, and then it's going to refer you to table 630.11A. And for the 80%, I can put a 91% duty or percentage on this. And then for the 90%, I can put 95%. So
Right.
you're going to do all these calculations across. So 12,000 VA at 91% gives me 10,920 VA. And for the 10,000 VA, I can take it at 91%, gives me 9,100 VA. And then for the non-motor, 12,000 VA at 95% gives me 11,400 VA. And then for the 9,000 VA non-motor generator arc welder at 95% gives me 8,550 VA. Now, this is where you're going to have to look at this, because now I'm looking here, I'm going to do a group of welders, but these welders I'm doing this group for in step 4 are not resistance welder. These are the motor, generator, and non-motor generator arc welders. And what it tells you is I can take the two largest at what? 100%. Okay? So looking at this, I've got 11,400, and the next one is 10,920 VA. Take those at 100%, gives me 22,320 VA. Then it says the next largest you can take at what? 85%. The next largest one is 9,100 VA. Take that at 85%. That gives me 7,730 VA. And then the last one that I have here is 8,550 VA times 70%. That gives me 5,985 VA. And then it says plus calculated from step 1 on the resistance welders, which allowed me to take the next one at 60%, add that 9,020 VA. So I'm just going to take all those loads right there, add them up together, and that'll give me a special appliance load of 45,060 VA. Now, what I will challenge anybody, go look at any other publication, any of them, and show and look and see if they show you how to do this type of calculation. Okay? This is a type of calculation that you're going to get into for a master's exam. Okay?
Yep.
So
I agree.
These are things that you want to get familiar with and know that when you get into a bunch of welders, to separate the resistance welders from your motor and non-motor generator arc welders, and know how to perform this calculation correctly. All right. Then we got my compressor and motor loads here. I had an air compressor at 24.2 amps. It was a 208 volt 3-phase. So that means I'll take the 208 volts times 1.732. That'll give me 360 volts. That'll help me put it in VA form, which is 8,712 VA. Then I had a grinder at the same voltage at 6.6 amps. Multiply that 360 volts, and that gives me 2,736 VA. Add that up, gives me 11,088 VA. Now remember, I'm taking everything at 100%, and then I'll do one of the largest motors at 25%. Then we have the largest, which is our non-coincident load, and I look over at 220.60. It says you can drop the smaller of the two, which in this case is the AC, and we had 24,000 VA heating load. Take that at 100%, gives me 24,000 VA. All right. Then I look at the largest motor load. The largest one here naturally is the air compressor. Take it at 360 volts, and then multiply that by 25%, your additional, and that'll give you 2,178 VA. Then just take all them loads, calculate them, add them all up together, gives you 106,751 VA. Then just go get all your neutral loads back here that had the check mark. You'll see right here. Just add all these check marks up right here, and that will give you a total VA of 19,780 VA. And then just take and multiply that out. Just or divide that. Just take the total for the amps at 360 volts because you had a 208 volt three-phase system there, and do the same for the neutral, and you'll get 297 amps for the phases and 55 amps for the neutral. And that, my friends,